Salute. How y'all doing? My name is Derek Williams. Shout out to my newest subscribers. The resurrection of Kenneth Thomas, Grandmaster Troll. Try to say that fast 3 times. Henry Velez, Queen Courtney, Papa D, Sanjay Kiara, Daddy Malbucks, The Christ Within, T Law Cable, David Lofton, 739401 Nat, and last but certainly not least, Absolutely Raven. I want to thank all y'all for subscribing and salute. The title of this presentation will be called Solar Geoengineering. And of course, I'm just one man in the comment section on YouTube. I'm sure many of you all have heard about chemtrails or geoengineering or terraforming the earth, all these phrases. For some reason, you have men with power that wants to control his fellow man. And I have a problem with that. But I want to let you see what madman Bill Gates wants to do with regards to changing our planet's atmosphere. And I know that I went through a little fiasco last week, but that's nothing compared to what people that are much bigger than you and I have in store for our planet. Not good. All y'all take care. Greenville, Mississippi till I die.
The record number of fires burning across Brazil's Amazon renewed global outcry over climate change. And big spending. $5 million from Leonardo DiCaprio, £10 million from the UK. Meanwhile, Bill Gates is backing the first high-altitude experiment of one radical climate change solution, creating a massive chemical cloud that could cool the Earth. It's called solar geoengineering, and it's highly controversial.
How long will it be that countries keep experiencing these climate impacts before someone gets desperate and says, hey, we need to cool the planet with solar geoengineering?
It would look something like this. Thousands of planes would fly very high and use nozzles to inject millions of tons of light-reflecting particles into the stratosphere. It would create a thin chemical cloud of those particles around the whole planet, blocking some sunlight from reaching the surface. It would mimic a giant volcanic eruption, which we know cools the Earth. Back in 1991, Mount Pinatubo erupted in the Philippines. It was the largest eruption to affect a densely populated area, creating avalanches and giant mudflows that left more than 700 dead and 30,000 homeless. It also spewed a cloud of 20 million tons of sulfur dioxide particles into the stratosphere. That chemical cloud was hundreds of miles across and reflected about 2% of sunlight back to space. And in 1992, the Earth was cooler than in 1991.
That is part of the mechanism, but you do this in a controlled way.
Modelling studies have found that it could reduce the intensity of heat waves, for instance. Apparently it could reduce the rate of sea level rise. It could reduce the intensity of tropical storms.
But it also comes with significant risks and uncertainties.
Things like mass famine, mass flooding, drought, of kinds that will affect very large populations.
It could weaken monsoons in Africa enough to affect crops. It could eradicate blue sky.
You start increasing the amount of diffuse light and you have less direct light, which is the same thing as saying it looks hazy and white.
And if the global community decides it should stop?
So you stop injecting it, and after a year, the cloud is gone, and you get this rapid warming at a rate much faster than you would get if we had done nothing. If you've taken out the greenhouse gases that are adding to the warming, then the temperature won't go up, it'll stay what it is. So if we don't stop emitting greenhouse gases into the atmosphere, we don't try as hard as we can to do that, then there's no point in doing solar geoengineering.
A 2016 opinion poll, conducted by the Harvard group doing solar geoengineering research, found that 67% of subjects support its use. One reason this technology is appealing, it's cheap. One study estimates it would cost an average of $2.25 billion globally every year for the first 15 years of deployment. Compare that to the $500 billion the U.S. government estimates it will cost just the U.S. by 2100 if no action is taken against climate change. Or the 1.6 to 3.8 trillion projected global spending by 2050 on low-carbon energy production. You can also compare it to direct air carbon capturing, another climate change solution backed by Bill Gates and by big oil. It involves sucking billions of tons of carbon out of the air, and at $100 to $200 a ton, it could be big business. Solar geoengineering, on the other hand, is so cheap that nobody currently stands to make money from the process.
But just because a solution is cheap doesn't make it a good one. It's cheap and dangerous.
It doesn't require a lot of materials. It doesn't require a big innovation. It basically affects the whole planet with one project. So that is not necessarily a situation that has a lot of profit opportunity, right? Because there's not going to be a lot of different people that can do it and compete in a marketplace.
Bill Gates is among a dozen individual donors and 14 foundations backing the first stratospheric solar geoengineering experiment out of Harvard. It's called Stratospheric Controlled Perturbation Experiment, or SCOPEX. A high-altitude balloon will lift instruments about 20 kilometers into the stratosphere, where it will release less than 2 kilograms of different naturally occurring chemicals, like calcium carbonate and sulfates, and then measure the change in atmospheric chemistry and light scattering. The Harvard group that runs SCOPEX and other experiments has raised more than $16 million, more than double any other solar geoengineering effort. And annual global funding has gone up from $1 million in 2008 to $8 million in 2018, with the majority of that funding coming from the US. The first phase of SCOPEX will cost around $3 million, with much more needed for wider research on solar geoengineering. To this point, stratosphere injections have only been tested with climate modeling. In the UK, a government-funded solar radiation management test called SPICE was cancelled in 2012 because of issues with patents.
We're not trying to develop any technology that is patented or where we want to make money with this later on.
A study last year found that no existing aircraft can inject the stratosphere but developing a new high-altitude tanker would not be technologically difficult or prohibitively expensive. Nozzles still need to be designed that can continuously blast out trillions of particles, and scientists still need to decide what chemicals those particles should be made of. But unlike cloud brightening, which is another solar reflection technique, the tech needed for stratospheric injections is not far off.
The technology is the main thing that's holding this back. The main thing that's holding it back is the uncertainty about what the exact effects would be and the positives and negatives of its effects, and the governance and decision-making process for implementing it.
Other radical attempts to control climate change have been tested in the past, like when one California businessman dumped 100 tons of iron dust in the Pacific to spawn the growth of carbon-absorbing plankton. But unlike small, sometimes rogue experiments, planet-wide solar geoengineering will require buy-in from the international community.
You know, in our simulations we found China got warmer and drier relative to the past when you stabilized global temperature, and India was now cooler and wetter. So you can see there how, international relations around using this technology could become complicated.
I mean, we can't even decide on what to do about emissions of greenhouse gases, and so how are we going to decide on setting the planetary thermostat?
There's the real concern that we won't be able to reach agreement, we being the entire planet, and so there's the prospect that countries just go ahead and do solar geoengineering, and that causes disagreement, conflict, tension, even possibly war.
3 years ago, the international community did come together when almost 200 countries signed the Paris Agreement on climate change, agreeing to limit global temperature rise to less than 2 degrees Celsius. Since then, President Trump has stated his intent to withdraw from the agreement.
The Paris Climate Accord is simply the latest example of Washington entering into an agreement that disadvantages the United States.
And global emissions are not being reduced fast enough to reach these goals.
We know what we should be doing. What we should be doing is reducing carbon emissions. So we're creating a moral hazard. We are providing an out for you where you can say, well, I'm going to fix this technologically instead of doing the ethically right thing to do.
It's way too early to give up on much more ethical approaches to climate change. Right? The future generations were literally in the room to question us on our dubious arguments. We wouldn't get far with some of the kinds of arguments we're trying to offer for neglecting conventional climate policy and going down this path.
For now, the failure to rapidly reduce emissions has prompted more exploration of alternative solutions like carbon dioxide removal and solar geoengineering. But scientists warn we will still need to reduce emissions too.
If we're not cutting CO2 emissions at the same time, from my perspective, there's little point in doing this because you would have to start using ever-increasing amounts.
No responsible scientist says that it's a silver bullet. All the responsible scientists say this is something that we deploy if we had to
alongside all the other stuff that we already have to do.
The U.S. Academies of Sciences is holding a series of meetings to study solar geoengineering, including one at Stanford this month. The committee will issue a report next year with recommendations for how, or if, solar geoengineering research should continue. Some scientists say the research is necessary in order to arm future generations with the ability to enact this backup plan, even though it seems nearly impossible now.
We ought to start working on this solar climate engineering problem right now with as much urgency as we can, so that if we want to deploy it in a decade or so, we understand what we have to do. This is a real moral horror, especially in a situation where we're not doing all the things that we could be doing to minimize the risks of climate catastrophe now.
But experts do agree that more public awareness is needed around solar geoengineering, because within a couple decades, for better or worse, it could be part of the solution, helping return the planet to pre-industrial temperatures.
Modelling evidence gathered over the last decade has pretty consistently found that a moderate amount of solar geoengineering could significantly reduce many of the impacts of climate change. But it can't be a solution because it doesn't return the climate system back to how it was. It doesn't do anything about things like ocean acidification. So whatever happens, we've got to cut our CO2 to zero. So right now, we need more research to understand this better and a broader conversation so that all of the world's nations have a seat at the table when this is discussed.